Welcome back to the deep dive. Our goal, as always, is giving you that shortcut to being really well informed.
And today, we're getting into something pretty foundational.
Yeah, we're looking at the tech that kind of holds up the whole Web3 idea, smart contracts, what sources call automated trust, right? We'll break down how they work, the mechanics, and then look at how platforms, maybe like Pi Network down the line, could bring this to, well, everyone with a phone.
Okay, so let's start with the problem. Traditional trust, it has this hidden cost, doesn't it?
Oh, absolutely. A huge invisible cost. I mean, think about it. Every contract, every significant transaction, it relies on someone in the middle.
A lawyer, a bank, maybe a notary.
Exactly. You're paying them to basically vouch for the agreement and make sure it happens. And that whole process, it's often kind of frictional.
Meaning it's slow, costs money, and it's just inefficient. Even with digital tools, that core friction is still there.
It is. And that's where smart contracts come in, promising to, well, smooth things out. So they're digital agreements living on a blockchain, right? And they just run when certain things happen.
That's the core idea. Conditions met, action executed, automatically. No human needed to step in.
Yeah.
Okay, so our mission today, get you, the listener, a really solid grasp of how this works, what you can do with it, and importantly, what the catches are.
Yeah, the challenges are definitely part of the story.
So the mechanics. What is a smart contract, fundamentally?
At its heart, it's just code. Pure digital logic, like if this happens, then do that.
The classic analogy, I always hear the vending machine one. Is that helpful?
It actually is surprisingly helpful. You put money in, that's the if, the condition. You press the button, then the machine gives you a drink, that's the then, the action.
And there's no clerk needed, no manager approval. It just works based on the rules built into the machine.
Precisely. The contract is the code, executing automatically based on those preset rules. Now, the magic happens when you put this simple logic onto a blockchain. That's what makes it revolutionary.
Well, why? What does the blockchain add? It adds 4 key things, characteristics that make it work.
Okay, number 1.
Automatic execution. We touched on this. Conditions met, the action happens. Instantly. No delays, no human maybe.
Number 2.
Immutability. This was huge. Once that contract code is on the blockchain, it basically can't be changed or stopped.
Okay, wait. Immutable can't be changed. That sounds good for trust, but what if there's a mistake? A bug in the code?
Ah, you hit the nail on the head. That is the double-edged sword.
So if I coded a contract handling millions and I missed a comma, metaphorically speaking,
It executes flawed, catastrophically, potentially. The immutability guarantees the rules won't change mid-game, but it also means bad rules execute just as faithfully as good ones.
that's a massive risk and a critical point often glossed over.
It really is. It's a fundamental trade-off compared to traditional legal contracts you can argue over or amend. Here, the code is the final word.
Okay, so automatic execution, immutability. What's third?
Transparency. The code itself and the record of its executions, it's all public on the blockchain. Anyone can look at it, audit it, see how it works before they interact with it.
No hater clauses.
In theory, yes, assuming you can read the code or trust someone who can. And fourth,
Is decentralization. No single boss, no central server.
exactly, the network running the blockchain, and thus the contract, is spread out across potentially thousands of computers worldwide. No single point of failure. Can't just be shut down by one company or government.
So that's why the blockchain is essential. You couldn't just run this code on, say, Google servers.
You could run the code, but you wouldn't get the trust. A central server can be hacked, shut down, manipulated. The blockchain provides that distributed, tamper-resistant environment. It links the history, keeps it reliable because it's everywhere. If some computers go offline,
The network keeps running, keeps verifying.
that's the idea. It provides the foundation for immutability and transparency that a single server just can't.
Okay, let's get practical. How do these things actually function? What are the components?
You need 3 main elements. First, obviously the code and the logic.
The if-then rules written in a specific programming language.
Right. Often something like Solidity, especially on Ethereum. This code defines exactly what conditions trigger what actions. And importantly for users, how efficiently that code is written affects the transaction costs, the gas fees.
Good point. Second element.
Recording and execution on the blockchain. You take that code, you deploy it, it becomes like a special kind of account on the blockchain with its own address.
And it just sits there, waiting.
Waiting for the right trigger, the right input or condition, then it executes. Verifiably, because it's all happened on that shared ledger.
Okay, code execution. What's the third piece? This is a crucial one and often tricky. Integration with external data, using things called oracles. Why tricky? What do oracles do?
Well, see, a smart contract lives entirely inside the blockchain's world. It's blind to the real world. It doesn't know the weather or the price of Bitcoin or who won the election.
So it needs data fed into it from the outside.
Precisely. Oracles are the services, the data feeds that bridge that gap. They provide the real-world information the contract might need to trigger its if condition. Like, if the temperature in London drops below freezing, then release insurance payment.
But doesn't that bring back the trust issue? If the contract relies on one oracle telling it the temperature, what if that oracle is wrong? Or hacked?
You've hit on the famous Oracle problem. It's a huge challenge. If your trustless contract depends entirely on a single, potentially fallible, trusted data source.
You haven't really eliminated the need for trust, have you? You've just moved it.
Exactly. And that's why developing secure, reliable, ideally decentralized Oracle networks is such a major focus in this space. Getting that external data connection right is key to making these contracts truly useful for real-world applications.
Okay, so assuming we can get that right, where are we seeing these things used? What's the sharp end of Web3 here?
Well, the most explosive area has definitely been decentralized finance, DeFi.
Right, using smart contracts for things like lending, borrowing, trading assets.
Yeah, all without traditional banks or brokers. The contract itself handles the collateral, the interest payments, the liquidation if needed. It allows people to essentially act as their own bank.
Then you have NFTs, non-fungible tokens.
An NFT isn't just the artwork file. The token itself is basically a smart contract.
Ah, okay. So the contract defines who owns it, maybe specifies royalty payments if it's sold again.
Exactly. It manages the ownership and the rules around that specific unique asset, often following standards like ERC 721 on Ethereum.
And DAOs, decentralized autonomous organizations.
Another big one. Here, smart contracts automate the governance, how proposals are made, how voting happens, how the group's treasury is spent. It's all encoded in contracts, not managed by a traditional hierarchy.
Okay, beyond the purely digital.
Supply chain management is a really promising practical use case.
Tracking goods.
Yeah. Imagine recording every step of a product's journey from farm to factory to freighter to store on the blockchain. Smart contracts could then automatically trigger payments when delivery is confirmed or verify authenticity. Huge potential for transparency and efficiency.
So lots of applications. What about the platforms where this happens? You mentioned Ethereum.
Ethereum was the pioneer, no doubt. It really showed the world what smart contracts could do and built the initial tools.
But it's not the only game in town now.
Not at all. You have others like Binance Smart Chain, BSC, now BNB Chain, which gained a lot of users by offering, generally, faster transactions and lower fees, while staying compatible with many Ethereum contracts. There are many others, too, all trying to improve on speed, cost, and security. It's a race. Which brings us to an interesting angle, accessibility, and specifically the Pi network.
Right. Pi Network took a different approach from the start. Started by Stanford PhDs back in, 2019?
Yeah, and their whole thing was making crypto accessible via mobile phones. Super simple. You open the app once a day, press a button to prove you're human, and you mine Pi coins. Eco-friendly, low barrier to entry. You could increase your rate by bringing others in.
Okay, now let's be really clear here based on the source material. Pi Network doesn't currently have open, general-purpose smart contracts like Ethereum, right?
Correct. That's a crucial distinction. The discussion around Pi and smart contracts is about future potential.
So what is that potential? Why bring Pi into this conversation?
Because of its user base. It has this enormous, globally distributed network of people already engaged with blockchain concepts on their phones. If Pi were to integrate smart contract functionality,
It could potentially bring those capabilities like automated transactions, maybe managing simple digital assets or NFTs, or even community governance like DAOs to millions of mobile users.
exactly, especially users who might not have easy access to traditional banking or even powerful computers. It's about democratizing access to this idea of automated trust, potentially through a platform people already use daily on their phones.
A fascinating potential bridge. But we need to circle back to the reality check, the challenges. This isn't all smooth sailing.
Far from it. Let's be blunt. Vulnerabilities are a massive issue.
The code bugs we talked about earlier?
Yes. Because of immutability, errors in the code can lead, and have led, to hacks and huge financial losses. Writing secure smart contracts is incredibly difficult, and the stakes are extremely high.
Then there's the whole legal side.
Legal uncertainty. How does a court deal with a dispute governed by a smart contract? What jurisdiction applies? Are they even legally binding in the traditional sense? These are largely unanswered questions, a big hurdle for mainstream business adoption.
And technically.
Scalability is still a bottleneck. Blockchains can only process so many transactions per second. That limits how many smart contracts can run, especially for things needing high speed. And as we discussed, the reliance on oracles.
Right, the oracle problem. Garbage data in, garbage execution out, even if the contract code itself is perfect.
It remains a critical dependency, a potential weak link in the chain of trust.
So, with all these challenges, what's the outlook? Is this tech stalling or...
No, definitely not stalling. It's evolving incredibly fast. You have major upgrades like Ethereum 2.0, aimed squarely at improving scalability. You have Layer 2 solutions being built on top of blockchains to handle transactions faster and cheaper.
And projects focused on accessibility, like the potential we discussed with Pi Network.
Yeah, showing the drive isn't just about making the tech better for developers, but also about getting it into the hands of, well, everyone. It's about changing where and how automated trust can happen potentially anywhere you have a mobile signal. Okay, so let's wrap this deep dive up. The big takeaway seems to be smart contracts represent a pretty fundamental shift. We're moving away from trust based on people and institutions towards trust based on code and mathematics recorded immutably. It changes how we think about agreements and value exchange online.
And seeing how projects focused on community and mobile access, like Pi, are getting decentralized tech into millions of hands globally.
It makes you wonder how quickly these automated agreements could start replacing everyday friction. Local deals, shared expenses, community projects.
Which leads us to our final thought for you, the listener. Think about your own daily life. All those little agreements or transactions that involve some hassle, some trust, maybe some inefficiency. Which one feels most ready, most ripe for the kind of automated, reliable execution we've been talking about, especially now that it's becoming accessible on the device in your pocket?
That's where the future applications lie. And hopefully this discussion is your first step into understanding that Web3 potential.
Thanks for joining us for the deep dive. We'll see you next time.